Okay.
Morning, everyone. Welcome to the first mechanical division webinar. This webinar series is entitled Building Code plus Welding. We have the mechanical division chair, chairman, Mr. Engineer Howard Chin, who will be starting off the presentation in regards to the building code. Then we will have Mr. Astley Scott, and after which we'll have Mr. Julian Dadag. I just want to say thanks to those who are on now. I see some persons are coming in, but we'll begin nonetheless. So I'll just give a brief introduction to Mr. Howard Chin. Engineer Howard Chin. He's now the mechanical division chairman. Howard Chin, a mechanical engineer for over 40 years, practicing in the fabrication and mechanical design field. As an inventor, he has a few patents to his name in diverse fields, has been a member of the AWS for 28 years, and is knowledgeable in the field of welding, consulting occasionally. Currently, the section chairman for the American Welding Society, Jamaica International Section, a past president of the GIE, and almost every other position in GIE. He is now the mechanical chairman again. He grows unusual fruit trees and occasionally shoots off letters to the editors of the newspaper when annoyed by engineering ignorance. So on that note, I will now hand it to the chairman, mechanical chairman, Engineer Howard Chin.
Yes, I will now begin the presentation. So let's go here. Okay. The relationship between the Bureau of Standards, well, the building code, and the American Welding Society.
One sec.
Yes?
Sir, Engineer Howard Chin, your presentation is not up.
Oh, sorry. Hold on. Let's see, share screen. Ah, here we go. Sorry about that. Here. Can you see it now?
It's coming up. Yes, we can. You can proceed.
Okay, right. So there has been a relationship between actually Jamaica and the American Welding Society from, shall we say, way back when the bauxite companies started coming here with their equipment and factories being built. So at this time, we are actually the AWS Jamaica International Section, Section 213. And let's see, here we go. It's one of the little things we get from them. That you know already. The building code for Jamaica is based on the International Building Code produced by the International Code Council up in the United States. And as a result, it is heavily weighted towards American standards. Now, what has happened here is that when we decided to, the GIE actually, and the Bureau of Standards, decided to use the IBC as their base document, they had to have application documents to convert it to a locally adaptable thing. And right now it is being reviewed after a long time, and the new stuff is being put into one document, not the IBC and all the other bits and pieces of the application documents. It's all going to be one document. The IBC references a lot of standards, and among them are the ANSI AWS standards. Okay, let's see here. The standards which are referenced are these: the D1.1 structural welding code steel, D1.3 sheet steel, D1.4 reinforcing steel, and also AWS A5.8 specifications for the filler metals and for brazing and braze welding. And although it doesn't reference this one, the AWS D1.8, the structural welding code seismic supplement, it is actually essentially just a part of D1.1. Now, this is what D1.4, I think, did I go too fast here? Let's see, no, D1.4, reinforcing steel bar. A lot of people don't out here weld them if they want to join it together. Say you have a extra long requirement for rebar, you can actually weld them according to the welding code. And that is one thing. The D1 is a seismic supplement. Is that, and this is from the, let's see here, IBC, International Building Code itself. This is a page around the back where it says reference standards. And if you see here, I don't know if you can see it, it might be a little bit small, but these are the AWS sections that are referenced. And this part for the International Building IBC is the structural parts. So the steel welding, sheet steel, and the reinforcing bar. The next page, this is from the body of the standard, where it references, well, it calls for the reference. This is for sheet steel. The next one, if you look at it here, if you look at the middle left, you'll see that the structural steel requirement is there, and for the cold form steel and the reinforcing bar. Now, the other parts here, you have the reinforcing thing here again on upper left. This is from the body again of the code, building code, IBC. And here we go into the, let's see here, it is the International Mechanical Code. Oh, hold on, what is this? Okay. We're, it is used for braze joints in piping and tubing. But we're not really going to be looking at that too much. And the next one is fuel oil piping and storage. You can see in the lower right-hand corner, braze joints. All of these things here are referenced. This is the plumbing code. Let's see, I think I went too fast here and did one here. This is for the plumbing code. You can see again, it's referencing the AWS for the brazing materials. This one, and there you go again, braze joints. Okay, now, what are the consequences of this? The IBC calls for the verification and inspection, and this requires certified welding inspectors, of which we have one, oh, no, two at this time, possibly later three, if Dwight Lewis tests and becomes successful as a CWI. But the main thing here is that all of these forms here, structural steel, cold form steel, and reinforcing steel all say shall be in accordance with the relevant AWS standard. And as a part of that, the welders have to be tested as well to be able to do the jobs that are required in the various codes. We're not going to have more cobblers around anymore. One of the things is that, oh, sorry, back up one. One of the things that happens is that right now in structural welding, a number of people welders are tacking things onto the steel in all sorts of places, which is not necessarily accepted by the D1.1, the structural welding code, because this can cause problems later on in the operational life of the building or structure. So there are a number of restrictions that will occur. Let's see here next. One of the things that goes on there is hydrogen comes from moist welding electrodes, and this comes out at dislocations in the metal, and that is not a good thing in structural steel in an active seismic zone, which we're in. Now, the lessons to be learned from this are that over the years, D1.1 has grown physically in size. In 1988, it was 22 millimeters thick. 1989, 30 millimeters thick. And getting closer to the current day, 37 millimeters thick. And then you add on a mere 9 millimeters of seismic supplement. Now, the thing is that, why is this? Earthquakes such as Northridge in California, hurricanes, and other problems that we've had. Oops, I think this went a bit fast. Causes changes in the building code. Now, one of the things that you have going on is, for instance, I don't know if the current engineers in structures are using the dog bone treatment for beams. I don't know if any structural engineers are here. Anyone?
You can type in the chat if
I'm not seeing that.
no one.
Well,
Anyone?
maybe you could do.
Typing it in the chat. But you can continue in the meantime.
Well, okay, that's the seismic problems for the steel structures actually drove a lot of this stuff. One of the electrode suppliers that was actually sued because the customer of the, well, he had a building, a large building, and it collapsed. And what he was saying was that it was the fault of the electrode. And what was happening there was that although the electrode was a little bit out of spec for the, well, not out of spec for later requirements, it was within spec at the time. So the electrode manufacturer got away with that. But that's been changed since. Yeah, so the other things that are occurring in the structures are, as I mentioned, the dog boning of the certain beams, for instance, where the beams are actually made to fail just before the columns. And they're weakened purposely by cutting out parts of the flanges or dog boning it. And also you have other parts where you have the joints to be welded are, how shall we say now, they are horizontal welds and vertical welds. And a lot of these things have to be done in situ. But I suppose you know that welding is making the electrode molten and then hoping that it will not drip away somewhere away from the weld where you want to put it. So often you have backing bars which are required to be put into the joint to hold up the molten metal. And a lot of engineers probably don't know that the runoff, the end of the weld, say at the end of a horizontal weld on a beam, probably flanges, you're not supposed to just end it. You're supposed to be able to make a runoff. In other words, you put on extra material, like a little tab on the outside edges of the joint, and at the start as well. So the start and end of the joint. And what you do there is you weld from the start on the tab and continue right into the joint and then off onto the other tab at the exit. And this prevents startup and shutdown failures, such as cratering or other things. At the beginning, you may have like a cold start, so that the material is not fully heated up to temperature as you're welding, and that can cause problems as well, and inclusions. So that is what we're looking at here. I think that is pretty much this bit of the presentation. I don't know if anyone else wishes to come in and ask any questions. Kevin?
Okay, is there any questions? Feel free to message or raise your hand. Okay.
Mr. Chin.
Yes.
Is there anything about corrosion, welding in a corrosive atmosphere in buildings as per your specs?
Not really. You have well, it is expected, of course, that you keep the joint clean before you weld on it. Now, what kind of corrosive environment are you speaking of? Sea spray, perhaps?
Yes, especially in a marine environment. The buildings close to marine. There's a sea splash and the like.
Well, that means you're very close to the sea then. Okay, you just have to, in that kind of case where you have maybe, well, hopefully not water being splashed into the weld, that if you have anything like that going on, you have to certainly protect it from actual water getting onto the weld. But other than that, you have the flux does a lot of protection for the actual welding going on. If you're using a flux in the material electrode. But other than that, it is just keeping away the actual spray or so from getting into the weld, actual water actually. So you can use maybe screens of some sort.
What about like in chemical plants, like the bauxite industry, where you have a lot of chemicals that affect steel?
Well, that is not that. Well, that is only afterwards, primarily. I don't think you have, say, the caustic dust is a minimal thing.
Sulfuric acid.
Yes.
sulfuric acid and like.
Well, sulfuric acid, yes, you have that. But you're not welding on a piece of steel that, or a beam or something that actually has sulfuric acid on it. That would be a really bad spill. But the only thing that you may have is if you have something like a tank that's leaked and you're patching it up, you may have to do something where you may have something like sulfuric acid. But in that case, I mean, what you do is you normally, say you have a hole, a small leak in a tank that's leaking sulfuric acid, right? What you do is you actually create like a little compartment around it so that the well would not be affected directly by the acid. It's much like ships. In ships, what you do if you have a hole in the bottom, they normally bung it with wood which expands into the space. They hammer it in and it expands and it's very, very tight. They trim off the excess that would stick out and then that would affect the building of the housing over it. And they build a little pocket, so little walls and then a cover over it. So that the patch would remain there. But that's an emergency kind of patch. And then you'd have to normally take the tank out of service or the ship out of service to do a proper repair. And that would be, in shipping, that would be the American Bureau of Shipping. Who is it now? I think Lloyd's. I think in the case of shipping, Masters Unlimited years and years ago used to be certified to Lloyd's to repair ships. And right now we don't have anybody out here certified to do ship repairs. But if we do have ever the logistics port, we should have a dry dock facility for repairing ships, and we should have then certified welders to American Bureau of Shipping or Lloyd's or others. Tankage, I think you have, well, I'm sure that the people would not like, the operators of the plants, bauxite or wherever, would not like to have their product leaking out of their tanks. In the case of the petroleum products, no, that's a difficult thing. A leak there, you don't exactly want to be welding on something like that because that's an immediate fire hazard. But perhaps in a later talk, you can have Astley speak to it when he gets his parts. Okay.
If you don't mind, I could just help with the response right now.
Okay, go ahead.
Yes, Mr. Reed, there and other participants, there is a requirement that all welded zones should be clean of extraneous material. No dust, no rust, no paint, no oil, no grease. And that would also include other contaminants like what you'd have in the bauxite that was here section that was mentioned. So you start with a clean surface. You weld, and the weld profile should be such that it does not promote corrosion afterwards. In other words, you try to avoid things like crevices, which would promote accelerated corrosion. Once you have done your proper welding, then the next step then is to make sure you protect the surface, whether by painting or for whatever other means you have to protect that surface from the environment that it's operating in. I don't know if that answers the question.
Thank you, gentlemen.
Okay.
All right.
Ashley, it's your turn.
All right. So
Here.
Astley Scott, you can. I will allow Mr. Scott to do his own introduction. I'm sure it is in his presentation. He has a wealth of knowledge as it relates to welding, and in terms of the certification of this, the role of the certified welding inspector, and in regards to training and certification. So, Mr. Scott, I now hand it over to you.
Thank you very much. I'm trying to find my screen to share it. Just hang on a second there. Let me just get back to slideshow. Are you seeing my screen now with
yes, there we go.
American Welding Society?
Yes, it is up. Just need to go into start from beginning.
All right.
Top left.
Upper left-hand corner.
Yeah, from beginning. Yeah, click on that. Perfect.
All right, you're seeing it now.
Yes, we are.
All right, good morning again. My name is Astley Scott, and I'm a Senior Certified Welding Inspector. Certified by the American Welding Society, which is the body in our region that does certification of welding inspectors. The closest other body that does so is the Canadian Welding Bureau. But for this presentation, we are focusing on what American Welding Society does, as American Welding Society documents and codes are what are addressed, are referred to by our building codes.
Oh, excuse me, Astley.
Yes.
Astley. Sorry, hold on. One sec. Oh, shoot. Oh, what is this? Yeah. Damn. Can't talk just now. Call you back later. Yes. One of the things that is happening is that also the American Welding Society and the Canadian Welding Bureau they recognize each other's qualifications. So that should be just a point. Okay, you can go ahead again, Ashley.
All right. All right, I've been involved with inspection for over 40 years now, starting back in 1981 when I was an NDT technician at Alcan Jamaica company. I've had some training in different areas, different venues, here locally and overseas and on the job. I've been to Hobart Institute of Welding Technology where I did an inspection course. I became a certified welding inspector in 1988, and then I did the upgraded exam and was successful in 2006 and became a senior certified welding inspector. And I'm still currently certified as a senior certified welding inspector. It does not mean that I did not have to examine again. I've examined again since then and was successful, so I'm still a senior certified welding inspector. Okay, welding inspection typically consists of a series of quality control checks. These are to ensure that the welds are done as required to the required quality and they are fit for the intended purposes. And to achieve this, there are different welding inspection techniques which may be applied, dependent on what the joint configurations are and the special defects that would be inherent in the type of material you're inspecting and the type of service and the material type and thickness, and whether or not the welding is being done in a shop or out on a site which may have all different kind of contaminants. A welding inspector is responsible for the inspection and the assessment of the quality and strength of the welding work. So the inspector has to ensure that the welds are safe and ready to function as part of the structure. And has to ensure also that the welding is done by suitably qualified personnel, and also, it's not mentioned, but also done to the specifications that have been approved for a welding project. Welding inspectors will also inspect equipment to make sure that they are the right kind of equipment that are being used, and also ensure that the welders adhere to all the safety regulations. There are 3 different levels of welding inspectors. There's a senior welding inspector, senior certified welding inspector. There's a certified welding inspector, and I have as a subheading there the certified associate welding inspector. And why I put that as a sub is that there's not an examination for a CAWI. You become a CAWI when you sit the CWI examination. You pass, but you pass at a lower level than what is required for the CWI. Then you are known as a certified associate welding inspector, which means that while you can do inspection, you have to do it under the guidance of a certified welding inspector or a senior certified welding inspector. You always have to be within sight or within earshot of a CWI or a CWI while you're doing your inspection, if you're an associate inspector. That's a requirement. And these different levels are achieved through education, experience, training, and examinations. And inspectors are really required to remain current, even though there are some codes which will allow the contractor to optionally use inspectors that are not current but have been certified in the past. The document from AWS which specifies what is required for certification of well inspector is the AWS QC1, and the current version is the 2016 version. It states in part, the purpose of welding inspection is to determine if a weldment meets the acceptance criteria of a specific code, standard, or other document. Other document here would be the job specific code, being like the contract document. And it further states that the inspector shall act to preserve the health and well-being of the public by performing duties required of welding inspection in a conscientious and impartial manner to the full extent of the inspector's moral and civic responsibility and qualification. And AWS is very serious about this, to the point where an inspector can lose his or her certification if it is proven that they have breached the ethical standards required for welding inspectors. All right, so I have here listed some of the most commonly used codes. Screen is showing right now the ASME codes that are popularly used. The section 1 for construction of power boilers, even though we don't construct them here, but we do repairs, which we will then have to make reference to the section 1. We have the section 8, which addresses pressure vessels. Section 5 is widely used in non-destructive examination. That's the examination that one of the type of tests that uses welding. We have section 9, which is a qualification code, which addresses the welding, brazing, and fusing qualifications. The B31.1 for power piping, B31.3 process piping, and what would probably be more interesting to you is the B31.9, which is the billing services piping. Continuing, there are some API codes as well, which are widely used right here in Jamaica. 1104, which addresses pipeline welding. The API 650, the welding of oil storage tanks. 653 has to do with the repair and alteration of storage tanks. And the API 510, which is the API pressure vessel inspection code. And even though these codes are primarily for the oil industry, you will still find that API 650 and API 653 are widely used in other tank constructions as well. because the similar rules would apply. And to be more, to get closer to what we are about, now we have the AWS codes. There's a B2.1, which is the specification for welding procedure and performance. So this is the AWS equivalent to the section 9, which is a qualification code. There's the D1.1, the structural welding code steel, and Howard mentioned the D1.8, which is a seismic supplement. There's the D1.2, structural welding of aluminum, 1.3, sheet steel, 1.4, the steel reinforcing bars. There's the D1.5, which is the bridge welding code. And the stainless steel code is the D1.6. The D1.7 is a guide for strengthening and repairing existing structures. All right, so I mentioned earlier that there are some things that will need to be in place whenever a weld is to be done. It should be in place first. Now, I have here listed some important documents. The very first document here is the welding procedure specification. This is like a menu, or rather a recipe as to how you're going to do the weld. So it states what material is being welded, how it is to be welded, the different current, the different positions, etc. And these have to be followed throughout a welding operation for a specific project. Now, the procedure qualification record is a test that is done to ensure that the WPS can fit the requirements of a specific project. And then there's a welder performance qualification, which is a test done to ensure that the welder or the welding operator can use the welding procedure specification to achieve the quality welds that are needed for a specific job. And while the code does not mandate the exact format for these documents, they do have some suggested formats. And if you move away from those formats, you still will be required to make sure that all areas that are covered are also covered in the format that you are using, right? So all essential information that is required for a WPS or a PQR or for WPQ, all of those have to be in whichever one you do. Even if you put them in a slightly different order from what they have as their suggested format, and they really call them suggested formats because no one is being tied exactly to that. And there are some codes, especially the American Welding Society codes, which allowed for the use of pre-qualified welding procedure specification. These are some WPSs that the American Welding Society has gone through all the testing processes for. For each one, they will probably have 20, 30, 40 different PQRs that they have done before they get to the final document. These they will sell to industry, so that kind of minimizes the number of WPSs that you have to be doing on your own. But there's a requirement that when you use these codes, these pre-qualified codes, you have to test them to make sure that you are able to use them as they have been designed. It's not mentioned here, but AWS also allows for the use of not remembering the exact term, but some standard welding procedure specification, which can be drafted under certain condition without testing and used without testing. But all the conditions for that are laid out in the D1.1. And all those conditions have to be met before they can be used. I have here a list of the different suggested formats from ASME and AWS. No, in welding inspection, there are two different types of tests that are done. There's a destructive test and there's a non-destructive test. The destructive test, when done, it renders the sample unusable afterward. Tests such as a tensile test And the tensile test is mainly used when you're qualifying the welding procedures, and that is you prepare the sample and you pull it to breakage to the point where it fails, and you make a recording of what is done. There's also the bend test. Bend test is also used in qualifying welding procedure and also used in qualification of welders. And there's a sharper test, which we don't normally use in our area. It's mainly used in the very cold regions of the world. There's also non-destructive tests, and these tests which do not affect the usability of a sample after testing. And these include things like, but not are not limited to visual testing, radiographic testing, which we popularly call X-ray, magnetic particle testing, liquid penetrant testing, and ultrasonic testing. And all these are different NDT tests that are commonly applied to welding. Okay, the welding inspector has duties before the welding actually starts, during the welding, and after the welding process has been completed. Before welding, the welding inspector has a responsibility to verify that the correct material is being used in accordance with the WPS and the design drawings, and that the materials being used are traceable through the use of the test certificates. And the materials here are not just the material that is to be welded, but also what you're using to weld, which are filler materials. And all the inspector also has to make sure that the materials are free from damage and from contamination. Inspector has to make sure that the WPS to be used is suitably approved and it is available to welders and inspectors. And I will just expand a little bit more on that. And this is because I have found in so many occasions a WPS is prepared, it is tested, qualified, and approved, and the WPS sits on a desk in an office, and the people out in the field who are doing the work never ever see the WPS. No, it is like sending your cook out to cook something, or your baker to bake something, and you keep the recipe hidden from the baker. So you're taking chances, you're leaving it a chance, right? So the WPS really is something that should be available to the welders, the inspectors, the supervisors, all who are directly involved with the welding process, because this is what tells them what they are to do, how they are to do it, and a lot of times what the desired outcomes are. The inspector also has to make sure that the welders are qualified to use the WPS that is being used for the project. And I'll point out here that there are some projects that require more than one WPS. Inspector has to make sure that the welding consumables are as specified by the WPS and that they are stored and controlled as specified by the qualification quality control procedure. We have a serious challenge with that part, especially when it comes to the use of low hydrogen electrodes. And the common one we use here is the E7018 electrode. It is a fight getting contractors and workers to store these electrodes and handle them properly. Now, these are low hydrogen electrodes. You don't want any kind of contaminants, any kind of moisture, as they are really susceptible to cracking. Howard mentioned that in his presentation. Most contractors refuse to even purchase an oven to keep them in. And these electrodes are supposed to be kept in an oven until they are ready for use. Right? So the inspector has a responsibility to make sure that what is being used is being stored and controlled properly. The inspector has to check the joint fit-ups that they are in accordance with the WPS and the project drawings, to make sure the tack welds are acceptable and up to standard, and that the weld faces are free from defects, contamination, and any damage. The inspector also has to make sure that where it is required, the preheat temperature and also the interpass temperatures are maintained within the required regions. Duties during welding. The inspector has to ensure the weather conditions are suitable. Just 2 days ago, I was testing some welders at a facility. They were outdoors working and it got very windy. I had to stop the test and move it indoors. There are some conditions you don't want people to be welding under. And this is not just limited to wind, but certainly it includes rain. The inspector has to ensure that the welding process is in accordance, the entire welding process is in accordance with what is specified by the WPS. Remember now, WPS is the document that instructs the workers how the weld is to be done. All right, the preheat has to be checked and make sure that that minimum preheat temperature is maintained. The interpass temperature where specified is to be checked and maintained. The welding consumables are that the right ones are being used and they are controlled as required. The welding parameters like the current, the voltage, travel speed, etc., they are within what is permitted by the WPS. So it's not what a welder thinks he should use based on his experience, but what the WPS specified that this is the range you should be operating in for this size electrode. So that is what has to be used. The inspector also has to check the root run to make sure that it is acceptable before the weld is continued. Gouging, we're done, and grinding, that has to be checked by the inspector as well to make sure that the proper workmanship standard is maintained. Interpass cleaning must be checked, and the inspector also has to make sure that whichever welder is being used is registered and qualified for the WPS that is being used. After welding, and some of this may take place during welding as well, each weld is to be marked for identification. We don't practice that a lot, but it is good for traceability because you don't want, when a job is done, you find 10 joints failed and you don't know who did them. It might be one welder who is responsible for all of this. So this is something that is important for the contractors to know. So this kind of record must be kept. All right. Inspectors ensure that the weld appearance is suitable for all NDT. The profile is correct, the cleanliness, etc. is okay. And the inspector has to visually inspect and assess all welds because they don't go on to further NDT tests until they have passed the first and most important inspection procedure, which is the visual inspection. The inspector has to check and ensure that the dimensions are in accordance with the drawing and with the code. The drawings will specify certain weld sizes, certain weld profiles. Sometimes it also specifies how the profile should be finished. So the inspector has to make sure that all that is being done is done according to what is in the drawing and what is allowed by the code. Inspector has to make sure that all modifications are included on the as-built drawing. Now, there may be some variations to some of the inspector's duty, but this has to be agreed in whatever contract arrangements the contractor or the owner has with the inspector. All right? The inspector has a responsibility to ensure that all NDT is completed. I didn't have it here, but completed also by suitably qualified people, and that all the reports are available for the records. He or she also has to monitor the repair work in accordance with the procedure. If post-weld heat treatment is required, the inspector has a responsibility to check to make sure that is properly done. Not necessarily to be there all the time, but look at the setup and check the recording charts to make sure that what is required is there, and keep copies of these as part of the whole reporting procedure. The last thing that the inspector has to do is to ensure that all records are completed and collated and made available to all relevant people. This is a picture here of, I have here now some pictures of some things that, some mainly local things. This is a picture of some tensile testing that I had done in preparing a welding procedure for a local contractor. The tensile testing was done at the Bureau of Standards. This picture here shows me looking at a side bend test that was done locally as well. This is not a local image, but this is what face and root bend transverse bend test looks like, and this is used for the qualification of welders. This is me as the inspector, and another inspector. This inspector is from Venezuela. We're doing some measurements and some welding tests. It was some submerged arc welding test that was done, some fillet weld tests. Let me just move on. This is some welding that was done at a project in Montego Bay, and some NDT was done. You're not seeing it clearly on the image, but the arrows are actually pointing to the cracks that were shown up by the NDT that was done. Magnetic particle testing was done in this case. You can see it a little clearer there now. You can see it a little clearer there now, that red line, which is the crack zone. Now, what we have here is a building that went up. The owners noticed some things that they did not like, and they asked for inspection to be done. And this resulted in almost all the wells having to be done over. The wells, this was for a roof support structure of a building here in Jamaica. Normally, you just walking by, you wouldn't be able to see these kind of defects. A lot of the wells were done locally. Most of the wells were done local. Some were done overseas and sent here, and even those had to be done over because not entirely over, but the majority of them were smaller than the size that was stipulated by the drawings, and the quality was another problem. I'm sure you can see. Well, Howard mentioned something about cobblers. That was probably done by one of those type of persons. But we won't get away from it unless we have the inspections done. A lot of these things would have gone unnoticed because it's all the way up here in the roof structure. Nobody walking down, and once they are finished, they would put up the ceiling, and nobody is the wiser that this is what is holding up the roof. This is the kind of thing that was happening.
Very bad.
What project it is, because it's a project right here in Jamaica. But as I said before, the majority of wells had to be done over. They were done over by a local contractor. In this case, this was supposed to be a beam that the beam was supposed to be spliced, and they didn't fit it properly, so there was excess space, and they used rebar to fill the space and then weld around the rebar. And again, this was all the way up there. You would normally see this. And all this could happen because there was not a welding inspector on the job who was there monitoring what was taking place. The welding inspector in this case was only calling when someone noticed something awry. Yeah. This is one of the joints that was done over by our local welders. And the fact that I said local should make you realize that a lot of the welding was not done by local people. This is the kind of thing that was happening. This well was a well that was done over as well by our local people. You see the red arrow there pointing to another part that still needs to be done over. The well was below the specified size, and the profile was not of the profile that is acceptable. And you will see some of these wells were actually already painted. So they were all completed as far as they're concerned, ready to put up the ceiling to hide all of that. And remember, as Howard mentioned, we are in a seismic active zone, right? But radar is pointing to a part that the drawing says should be welded, but they welded the two sides and did not weld the end as required by the drawing. That's the well size being checked. That well was below the specified size. That's a fillet well gauge being used to weld to check the size of the well. I don't need to say much about that. You can see for yourself. This is another project here in Jamaica. This well was designed to have backing strip, and they welded it without the backing strip, and this is what was happening. This too was a roof structure, and also you'll notice the paint that is close to the well. The paint was not clean off from the well zone. The code calls for at least an inch of clearance between the area to be welded and the paint. And this was not done. This well should have been a full penetration well. You can see that it did not come all the way through. Again, no inspector was on the job. This is another joint that the well did not come through. You can see it in the mirror there. Same thing here again. The paint is right there, right next to the well here, and the well has not penetrated all the way through. This one they had done over, but they still had a crater at the end. They did not have that runoff tab that Howard mentioned. But even without the runoff tab, a suitably competent welder should be able to fill that crater without leaving the crater there. That's a gauge being used to measure the reinforcement height of a well, of a groove well. This is the underside of a well that should have been a full penetration well. Well, these are some of our welders doing well build up to a part that belongs to Petrojam. So some pressure vessel repairs. So a welder doing a welding test, a pipe welding test in the 6G position. So the pipe is positioned at a 45-degree angle, fixed, and then the welder moves around and completes the weld. That's an NDT inspector doing the inspection on a job here in Kingston. I think this was at the cement company. And that gentleman and ladies, if there are ladies present, completes my presentation. Howard mentioned that there are 2 welding inspectors here in Jamaica right now. The fact is that if we were doing the things as we ought to do them, we would have a lot more welding inspectors. There's really one active welding inspector, and that's me. The other welding inspector is not finding inspection work right now and has resorted to teaching. Right? We really need to get this kind of thing going the right and proper way, so we don't end up with people being sued. As Howard mentioned, those 2 buildings I showed you images from, they could have reached a point where they could have reached a point where they failed because of the quality of work that was there.
Astley.
Yes, I'm trying to get back to my
yes, right. One of the other things that might happen there, is if the insurance company looks at something like that has failed and the welds are not proper, they could say, hey, this is not properly done in the first place, so they could avoid paying out for the repairs or replacement, which would not
That's
be a
true.
good thing for the owner.
Mr. Scott,
Yes, sir.
a very good presentation, man. I really appreciate it and enjoy it. But it begs a lot of questions in my mind. Firstly, with only 2 certified welding inspectors in Jamaica, what is being done to increase the amount of welding inspectors that could give good coverage? All right. The next thing is, when you do the repairs, do you have to come up or recommend or ask the contractor to come up with a methodology to do the repairs, or you just wait until they finish, then you do the inspection? And there's much more questions I can ask, because what Howard spoke about, the insurance company refusing to pay if there's a catastrophe. Also, the problem of failure might happen, because if you design a particular well with a particular beam and the well is not properly done, the possibility of failure is there. So your presentation has enlightened a lot of things. Thanks very much, sir.
Okay, Peter, thank you. On the subject of the number of inspectors, I think it's a matter of demand driving supply, because it's cost. It's cost you'll be adding to a project, and many people try as best they can to avoid the additional cost. I have personally experienced where I've been asked to give information on projects, give my prices, and it's submitted as part of the project. The project is approved, and I may just hear about it. By the way, contractors avoid using, because they don't have to pay that additional fee. So it's all a part of demand, and if they can get the people, if they are not ethical enough, and they find they can get away with that, they will do that. They finish the job, go about their business, and they don't look back unless something happens. What I have found out that in other jurisdictions, this kind of thing is driven mainly by insurance companies. The insurance company may insist that, look, you have to have this thing done, which is why you have some companies who will insist on things like that. Like, for example, I'll use Petrojam as an example. Based on the kind of operation that they do, there are some projects, for instance, that no welding is allowed unless an inspector is present on the spot while the welding is taking place. Right? And this is covered by, this is a requirement, I think, from their insurers, because they have to make sure that everything they do meets the codes that are specified. So until we get to that point where we will live up to the code requirements, we will continue to have people avoiding quality. Quality costs, but quality pays off. Now that job that they had to do over all the wells, it would have cost a lot less to hire an inspector in the beginning, have the thing done properly one time, and have it accepted, rather than having to do over everything. And let us not forget that there is the potential cost of loss of life or injury. What was the other question again, Peter?
The methodology for repairs.
Okay.
Is that something that the inspector involved in, or you leave it to the contractor?
No, the inspector would be involved in that, because there should also be a repair procedures. At times, the welding procedure will suffice, but you may have to do an addendum to that. Say this is how you would remove that defect, and then you would re-weld it using the welding procedure that is specified for the project. The inspector has to monitor that. The inspector has to check that it is done properly, and also that the required NDT, the same NDT process that found the defect in the first place, would then be used to make sure that to ensure that the repair was properly done. So the inspector has to be involved.
And finally, Scotty and Howard,
Yes.
how can we get rid of the cobbler? Because there's a lot of them out there. A lot of them. When you see them work, man, you wonder what is happening. Is the standard dropping? And the man tells him the welder and him can't get a proper bead. Him don't know whether or not the size and the root well and the like. How can we get rid of this? And is the government aware of this and trying to train people? You know, that's the issue I find I have when I do any work. And contractor bring on some welders, but there are more cobblers than welders.
What you should do is perhaps test them.
Again, Peter, it has to do with demand driving the supply. Now, if quality is demanded, then the supply that you get would be of the high quality. And right now, if a man gets a job to do and is not concerned about what the finished quality is, then he will use a welder that costs him $10 rather than use the competent welder that costs him $20. Right? And if this continues long enough, then you'll find that even the good welder over time becomes the cobbler, because then he's not going to be putting out his efforts to produce good welds when there are other people just doing very ordinary work and getting paid the same rate as him. So it is us in the industry who need to drive it. It's the contractors, the owners first, who need to demand that the quality is done, and the contractors who don't try to shortchange the requirements, but make sure that they live up to what they signed on to. That is what we'll drive.
And the insurance companies.
That's right.
Right. How can we get the insurance companies to make it mandatory that a welding inspector is present on site?
Well,
They can start increasing the premiums.
Mandatory. We can get them to make it mandatory. It's just a matter, I suppose, of dialogue and making them aware of what is.
Well, the building code calls for the AWS 1.1 and other codes, right? It's just to now have the enforcement, the regulations to go along with that. Then you're going to have some improvement, but also when you have the insurance companies saying we're not insuring that thing unless you do it according to code, then you're going to see a big change.
Agree.
I really hope, though, that we don't sit around and wait to be forced to get to that level of standard. We really have to do our part, all of us.
Yes.
You know, gentlemen, the last time a big accident happened that can tie to welding, and it was when I was a little boy in high school, you know, by Kaiser, North Coast, Discovery Bay. But we don't wait to have something like that happening, because it will be catastrophic and a loss of life. So we in this profession need to send signals, as you said, to the insurance and to the government that something needs to be done before something fatal happen?
Well, the thing is, you know, if okay, look at it this way, right? If you have the situation that we have right now, if inspectors went through all the steel frame buildings and so on that are up there and said, okay, well, this one is not welded properly and it's likely to fail if you have a load on it or extra loading on it due to earthquake or hurricane, then if they say, hey, we're not insuring this, and there's no hope of getting a payout from insurance if you keep on doing what you're doing, then certainly you're going to have an effect. But the premiums for insurance as well should be adjusted according to the structure itself that was done. Okay.
I had an experience a couple of years ago as well that I was called to inspect some wells at a building. They were putting in an elevator shaft. And none of the wells met even basic required standard. The contractor was there the first day I went, and that man literally threatened to get violent. The owner for the place had to remove him from the place physically because he started cussing me out. I didn't know him, but he was cussing me out. So we have to get to the stage where the owner for a building insists that this must be done to code, and that is built into the contract. And the contractor don't try to Jim screech and hide from it, but also live up to the expectations. Right? Once we have that going, I'm pretty sure we'll have more inspectors and we'll have more quality welders. We have a lot of quality welders, you know, but a lot of them don't even bother to stay in Jamaica anymore. They gone overseas and work.
Yep.
They get paid properly and they do proper work.
And I have pride. I have pride in what they do.
Right?
Yep.
All right. Thank you so much, Mr. Scott. It was an excellent presentation. A lot of knowledge was shared. We will now go to the third segment. We will have Julian Dadag. I'll just do a quick introduction. Julian is a graduate of the University of Technology, where he studied information technology. He's a Hart Level 3 certified welder, a metal fabricator, and a budding metal artist. He's a member of the American Welding Society, where he currently serves as the treasurer for the Jamaica section. In collaboration with his wife, Julian will soon be launching a boutique development company with a focus on sustainability, resilience, and conscious living in the Caribbean. I now hand it over to Mr. Julian Dadag.
Morning, everyone. So my presentation will be more focused on not only the codes, its implementation, its history, and our current situation in the whole spectrum of welding, from common welding all the way up to structural welding. So I'm going to start. Share screen. Oh, screen 2. Okay, so as I've mentioned, what is the state of welding in Jamaica? Well, frankly, 10 rod is king. And as I go into it, I'll go into the history of where we are coming from, the attitudes of welders, the value of welders, where they get their information. And hopefully we can galvanize change from where we are now to a better and more structurally sound world. So this is a shout you hear. You go to any little hardware all the way up to National Supply on Constant Spring Road. This is the call. So me about a 10 rod. What is 10 rod? 10 rod is 1/8 diameter E6013 welding electrode. It by far outsells everything else on the market. It's the welding supplier's bread and butter. They are not going to rock the boat. They are in it for making a profit, and their position is, unfortunately for us, one of power, in that a lot of the times, for want of a better term, cobblers that Mr. Chin speaks about, they want to weld stainless steel. They go to the shopkeeper, proprietor, and ask, what we can use for weld stainless steel? And the proprietor is in no way a welding expert. He's a salesman. So, well, you use stainless steel rod. What can you use to weld aluminum? Well, you use aluminum rod, so on and so forth. What he's exposed to basically reflects what the welders will use. The power plants they sell, once it's within the budget range, and I'll talk about that later, of the cobblers or the welders, for want of a better term. So where did we come from? Where did this all begin? It all began in the country, at the time, the country's largest industry, which was sugar. So, I mean, sugar factories are large steel buildings. They have large machinery. They have gantries. They have walkways. Everything is steel. Sugar factories are also power plants, if you didn't know that. That during harvest time, they burn the bagasse and they run turbines, generate electricity for themselves, cut off GPS, so on and so forth. Of course, with sugar factories came British people. British people, their mannerisms, how they deal with workers, their processes, their policies, their biases, and the technology. The most poignant to us is the AC transformer welding plant. And well, as I'll mention later, is that most welders out there use an AC welding plant, and how it affects how they weld, their attitude towards what they weld, what they choose to weld with, and their whole mindset. It becomes obvious, as most engineers know, the tool you use determines the product that comes out at the end. And you shouldn't blame a tool, but in this case, a lot of the time, not only the tool being the welding plant, but the electrode you choose, how you keep it, as Mr. Scott said, how you prepare the metal, how you maintain temperatures during welding, all of this matters. It does matter, and it does matter because we have adopted a kind of not my monkey, not my zoo scenario, where you weld this structure, it goes up today, it doesn't drop down tomorrow, it doesn't drop down the day after that, all is well. You move on and they put up another structure, and so on and so forth. And maybe quality control may be compromised because a contractor wants to meet a deadline or a budget. So we have all of those factors to deal with. There's also the factor coming from the sugar factory and the social bias that a welder is a dirty person. A welder is a dirty job. It's not seen in the environment like in the US. A welder is a blue-collared worker. We don't have that stigmatism here because we've inherited a British hierarchy of social stratas. So you have the lawyers, doctors, whoever, and then you keep going down the line, and the welder is the one you look down on, because between the welder, the greaseman, the mason, they are the bottom end people. So they are not important. So what they do is not important because they're not collecting the money, and the contractors keep the strata in place, even though they are wholly dependent on these workers. The whole mindset that they are dirty workers has been kept since these days of field factory workers and so on. So moving along, where did number 10 rod come from? Why specifically do we keep this terminology? Well, back in the day, and it still goes back to the factories, is that the number rods, the electrode diameters were associated with the thickness of sheet metal or metal that you were supposed to weld. So it's been passed down from generation to generation. So as you can see, number 8 is a 5/32 rod. A number 10 is a 1/8 rod, and a number 12 is a 3/32. Always know it's associated with E6013. Now, why E6013? Why is it so prevalent? One, they're readily available. Like I said, the proprietors don't want to work the boat. They make money. It is their bread and butter. You know, you can't wrong them. They're not in the business of weld stability, structural stability. They're in the business of making a profit. E6013 sells, so sell E6013. They don't need to do promos like Pepsi or Red Stripe or anything. Oh, the better drink, the stronger this, the more caffeinated, whatever, energy boost. Nobody advertises this is the stronger, better electrode. No one does that except the welding companies in the US. The electrode works on machines, and I'll go into the machines a little later, that the welders currently have. It's scary, the machines that they have and they actually use, but most of them use. I'm not saying, again, I'm speaking about a spectrum of welders, not structural welders. These are all the structural welders. These are all the TIG welders. These are me. Across the board, when you think about it volumetrically, there are a whole bunch of grill man, cobblers, like Mr. Chin keeps saying. Whole bunch of grill men, a whole bunch of little guys that do smaller work. Unfortunately, they filter into the contractors' field of view because they work for cheap. The other thing is E6013 don't require special redrying conditions, special storage conditions. Most electrodes that are used for structural welding, which are the low hydrogen electrodes, require special storage. They come sealed, and once you break the seal, most of them you have up to 30 minutes to use them under normal conditions. That is, well, normal atmospheric conditions. So not rain, not snow. So, well, we don't have snow, but just saying. Under normal conditions, once you open the sealed packet or sealed container, you have about 30 minutes to use the electrode before they start to lose their chemical properties. After which you have to dry them in an oven. Again, I think Mr. Scott mentioned that contractors don't even want to buy the oven because that's another cost. You have to run electricity to said oven on location. And then the electrodes can only be rebaked once, and then they are basically trash. So 6013 can also be welded in any position except vertical down. Now, if you know welders and they are using a stick electrode and they are using 6013, the terminology is lock it up or tie it down, which is they weld down, meaning that they use gravity as a crutch. But unfortunately, this electrode is not supposed to be welded in this position. And if you go to most malls, a lot of public spaces, you can easily, I didn't want to show the pictures because I'm sure Ashley has terrorized us enough with those large, but you go to enough public plazas, any large building with metal structures, even if they're not supporting, and you look at it, you notice that it's full of porosity, it's poorly done, and is basically a hazard in waiting, or well, it's a hazard. So cost, as most things are, the electrode is cheap. It's cheap also because it's in abundance. It's cheap. Everybody wants to use it. It helps people to keep in budget. Combined with all other factors, money counts. So everybody uses it. Again, the proprietors sell it in volume, so they're happy keeping it down in terms of cost. And of course, they are not trendsetters. We can't expect shop owners to force welders on the road to use a certain type of electrode because the truth is it's not in their favor. I mean, I don't think there is a legal premise that say we can sue the shop owner for selling somebody an electrode, because in truth and in fact, it should be the welder that should be responsible enough or knowledgeable enough to know the application of their various electrodes. So moving on. So the shift. So we are now seeing in our modern era, away from sugar and its codes. Oh, sorry. It's the infrastructure involved in sugar, which is the machinery, the field machinery, the buildings, and so on and so forth. So the shift in Jamaica has come about through the bauxite industry, as was mentioned before by Mr. Chin, and the power company. So it started with them. So that was before Petrojam. I think Petrojam before was a oil refinery. So the main shift to North American codes and standards and practices came through the bauxite industry. Welders were introduced to DC current welding, to cellulose electrodes like E6010, to low hydrogen electrodes like 7018. And more importantly, they were required to follow these codes, and inspection was necessary. Why low hydrogen electrodes? Well, basically, what does hydrogen do when it's in a steel weldment? It causes cracking. So the use of low hydrogen electrodes, the EXX18s, or I don't know, Ashley can elaborate on other kinds of electrodes, were necessary because of the need that structures could not fail, because again, it would be catastrophic. And although the gentleman mentioned that something has not catastrophic happened, happened, and the last one was the bauxite company. That isn't true. People crash all the time in cars, and the cars are ripped apart, and chances are the weld repairs or whatever on the cars failed, and it was probably done locally, and I will talk about that a little later as well. It's just that we haven't reached the tipping point where 100 people have to die in a building for someone to say, we need to change. We are slowly going about the change of shifting to newer processes and stuff, but it's hard to break tradition. Nobody wants to rock the boat. And so what we think of a welder becomes important. So right now, we suspect a welder has this kind of equipment: nice European big red, big blue, ESAB, you can call the names out, Everlast, Kempe from Germany, beautiful machines, modern machines. Unfortunately, that is not our reality. The reality is a lot of welding machines that the cobblers use are older machines, almost museum pieces, or if not museum pieces, they're, old. And the truth is, the only reason why quite a few welders out there have adopted 7018 is because 7018 can be run on a AC machine. So at the bottom is our reality. It is our reality on the field. It is our reality in schools. Not to say that the machines at the top don't exist, because we have welders, again, who take pride in their work, who are knowledgeable, who understand the process, who understand productivity. And they use newer machines if they can afford it. But the truth of the matter is they are far outnumbered by the cobblers. They have higher overheads. The cobblers will throw up a line on the potheads outside of a building. And as you can see they're just an electrocution hazard waiting to happen. But that is our reality. The cost of buying a newer plant is way above what the average welder would want to spend to see as an investment, because again, work is not consistent. Work is as the contractors demand, or as is the client wants to pay. If the client doesn't want to pay for a skilled welder or pay at a certain rate, what keeps happening is they keep balling down the prices. And if you keep balling down the prices, why upgrade my weld? Why you spend $1,500, $2,000, $3,400 US to purchase a welder, to then import it, to then have my prices be balled down. It's not practical for them. So why change? And as Mr. Scott said, there are quite a few qualified welders out there, but they migrate from job to job to job, and they don't, again, they need to invest in a an expensive welding plant is just not in their purview. They have rent to pay, they have bills to pay. So they don't see the need unless the client comes with, the contractor comes with a rented welding plant, or the contractor owns a welding plant. A contractor actually got a good chuckle when I was doing my interviews about he only lets the welder weld with the welding plant if the welder is in his line of sight. Once the welder is finished welding, he packs up everything in his truck and he drives off. You know, this is the kind of attitude, this is what welders have to deal with when you have such an informal structure for them. Now moving along, yes, there are newer processes. So Mr. Scott mentioned one of them, which was submerged arc welding for the project he was inspecting. So companies and individuals that require higher productivity rate, they have retooled and invested in flux core arc welding machines, gas metal arc welding machines, and continue to do well and continue to do good work. However, like with TIG welding, the acquisition of shielding gas tends to be an issue sometimes. If you don't have a stockpile of argon, you definitely cannot easily get a good blend of, say, for example, 90% argon, 10% carbon dioxide, or 98.2, which you need for pulse spray for GMA. Oxyacetylene welding, another older process, is sometimes used by car bodymen. But again, the technology in the car bodies have changed. They are, it's called, a lot of the bodies now are made with advanced high strength steel, AHSS, as they call it, in the automobile industry. And people are just migrating away from using oxyacetylene because it cracks after a while, because the process has a high heat affected zone. It causes annealing, and the metal becomes softer and increases the risk of crack. And of course, on a car, that means structural failure. A car is constantly in motion, a car is constantly vibrating. So a lot of body workshops are adopting flux core arc welding and gas metal arc welding to use. Tungsten arc welding tends to be, and still is, a specialist welding process for industrial stainless steel applications, exhaust systems, automobile repair, in terms of the actual engine, not necessarily the bodywork, but welding the aluminum engine blocks, some of the steel components, and of course, marine repairs. So again, with this process, the whole availability of gas cylinder, especially to get a smaller, more portable gas cylinder, is yet another hurdle that a welder has to jump to, say, become more modernized or to upgrade their equipment. So again, why change to a gas process where they have to haul around 100-odd-pound tank? They can't get the smaller tanks. When you do get the smaller tanks and you do give it to IGL, it takes a month to 3 months to get back your tank. So I mean, you can't wait along that time, and you have a client bearing down on you and they have deadlines. So just weld it with stick, you know. So the current situation overall is that HART does training up to level 4, which is the national vocational qualification. And they say it's a management level. There are currently, we as AWS are currently involved in the whole restructuring of the programs to be more aligned with the AWS. The only AWS testing facility, Welder testing facility on the island is housed at HART's Entai, which is down by 3 Mile. As we stand, there are less than 100 welders AWS certified. However, AWS certification for welders expires every 6 months. And while an employer, and Ashley can confirm this, an employer can keep logs of a welder to say that they've welded certain weldments in certain positions on certain types of material that will assist them in keeping their certification. I'm not too sure of how that process works, but most welders don't even do that. Most welders only get recertified on a as needed basis. So if the job, the contractor, the client, the owner, whoever does not require them to have the certification in the certain type of metal, in the certain type of position, it's again, not my monkey, not my zoo scenario where they don't care. They will just go out and weld. And as Mr. Scott has shown, you see the results. So the way forward, where do we go? The number 10 rod cannot continue to be king. It's just a recipe for creating hazards. Our national building code has changed. The GIE itself must be part of the drive for this change as well, in terms of attitude, in terms of sensitization of the public in general, because while you do have the owners, a lot of owners operate their projects or their buildings like a black box. They get it from the contractor, they get the architect to sign off on it, they get the engineers to sign off on it. They are not out there every day walking around with, you know, the site men. They don't know what a good weld looks like until it fails, unfortunately, or until it's absolutely certain that something is wrong. And in whatever limited exposure they do have, they look up in the ceiling and said, well, that's not 90 degrees, or those things aren't butted together. Those things aren't holding. At that point, you know, there is reason for somebody in the public sphere to say there's something wrong. It shouldn't reach that point. And there are increasingly more and more of these buildings going up. Global safety standards have moved, shifted. They continue to shift. It's in constant evolution. Again, as Mr. Chin gave a synopsis on how thick the code book keeps getting. I think it's updated almost every 4. AWS code books are updated almost every 4 or 3 years.
Are required to be updated every 5 years.
4 or 5 years, okay. So, and you guys as engineers have the power to drive the change. Nobody's going to listen to the dirty welder. It definitely, nobody trusts contractors. That the general consensus is that the attitudes of everyone needs to change, because I can't remember the name of the gentleman said, we are basically positioned for something horribly catastrophic to happen. Are we going to wait for that event to occur? Thank you very much.
Thank you, Sir Julian.
Kevin?
Yes, an
Is there
excellent.
something you should say about the test facilities and training that would come up next.
Okay. Test. Oh, you're going to touch on that.
It was the third one, but you skipped over to the fourth.
Oh, all right.
Okay, very short.
All right. Well, I'll hand it back over to you. But first, is Any questions for Mr. Julian at this point? Okay, seems like everybody was.
Sorry, not a question, but just a comment.
Okay.
Support of what Julian said. Really, the GIE is well positioned to drive this change, because I'm sure that within GIE you have persons who are owners or work for owners, and persons who are contractors or work for contractors. So when the sensitization takes place within GIE, then GIE is in prime position to help to drive the change
Okay.
that is required.
Agreed.
Gentlemen, follow up on what Scott is. We have certain standards and certain ethics we have to follow. So until we start very conscious of that and make sure that we follow it through, you're going to have problems, because if an engineer design, and this is design that he comes up with, the contractor has to follow it, the notation and bring it to the owners, and then as Ms. Howard said, it goes straight up. So yes, we have power, but we have to make sure that we have power and use it.
Hello? I think it's gone off.
No, I think he stated this point.
Yeah, okay. Kevin, speaking about the training and testing of welders, there is actually an ATF, as Astley said, but this was, I don't know if the current GIE executive knows or remembers how the ATF came about, because the Jamaica Welding Institution, which came out of the GIE, and it was formed because the membership was not all engineers.
Okay.
So Noel Gunning, the president at the time, said that there should be a different kind of organization to deal with it. So it was formed, and in 1992, the Jamaica Welding Institution was formed, and also at that time formed signed a cooperative agreement with the American Welding Society. So it's been around from that time. Now, the idea of getting the accredited test facility came about, well, let's see here. Yeah, it came about that time, and it wasn't until the later part of the 1990s that the accredited test facility was actually assessed by the AWS and commissioned into operation out here at Papine. And the persons involved were Noel Gunning, the past president of GIE, Lawrence Nalty from VTDI, Dor Campbell, another engineer from GIE with the Bureau of Standards, and Rupert Gross from the Jamaica German Automotive School, and Astley Scott. Now, the thing is that it was headed by a tripartite set of people. It was GIE, Bureau of Standards, and Hart Trust. And that is what went along. Now, in the location was up at Papine, and it lasted until a few years later, but the accreditation lapsed because it was removed from there and moved to Ashenheim Road. And since that time, we've been, the JWI and the AWS section, I've been trying to reestablished that accredited test facility. The accredited test facility does testing and training. Well, they do some training down at ANSI for welders down there as well. So what they're doing is now trying to change their curriculum to more, as Julian was saying, more to shift towards the AWS curriculum. But level 4 is supposed to go improve until they can actually test and certify to AWS level 1 certified welder, which is entry-level welder for those who don't know. The current situation is that in a couple years ago, it was through our involvement with the ANSI people and Hart, it was reestablished, and we are now having a current ATF certified by AWS operating here. So we can get the welders, but we just have to push to have it done. I don't know if Astley would like to say something about the testing formats. Astley?
Yes, thank you. Yes, you're right. It was reestablished back in, I think, about late 2016, early 2017. An assessor was sent here an auditor was sent here by AWS, gentleman out of Mexico, to assess the facility, and he was satisfied with what he saw in place, and the facility was accredited. Accredited, but has barely gotten off the ground for a number of different reasons, which I am not privy to everything, so I won't try to explain. But needless to say, if we really don't get this thing up and going, we stand to lose that accreditation again. And the accreditation, having an accredited test facility in Jamaica, can really help our local industry. It will help us to help in standardizing the certification of our welders and also in maintaining their certification. Because whereas right now, welders are required to, based on the very informal situation that we have existing, welders are being tested. Some welders are being tested none at all, and some are being tested quite often. If we had the ATF up and running properly, then their certification could be maintained with their employer attesting to them being current with their welding and their welding quality. We don't have that. Julian mentioned the migratory nature of our welders, and it's not just migratory going abroad, but migratory within the country. Contractors don't keep people who they are not using at a time. So the welders move from contractor to contractor. Move from one contractor to another contractor in another facility. What happens to the certification? It has to be done over, because the contractor who paid for it in the first place is not passing it on to the next contractor. And the company might be a different company who is not seeing that certification. So he asks for certification, so it has to be done over. So having an accredited test facility up and running and functioning as it ought to can really do wonders for our welding industry here in Jamaica. But we have to get it going. Right now it is there just idling. That's my piece on it.
Okay, well, that's about the end of the session, but there's some questions that may occur from this last little bit. Any questions? One of the things that Astley was showing was the very inadequate welds that were done on some of these buildings. Now, one of the things that you can have a problem with that would cause that is actually not having a powerful enough machine to drive the current to deliver the heat that is required to melt the electrode properly into the weld. So that again is a possibility that somebody had a machine that was not up to capacity, the capacity required. So that is another problem that occurs sometimes as well. I know personally some contractors, fabricators actually, who are looking at getting into say flux core or MIG. And what has happened there is that they tend to not buy as large a machine with a duty cycle that's required. So the heat input is insufficient to activate the flux in the flux core, and also the heat required to melt the substrate, the base metal, and the electrode is sometimes insufficient. And that is where you get incomplete fusion failures of the weld, and inclusions, and a lumpy looking weld deposit. So that is another little problem. Okay. Kevin?
All right. Thank you. I think this brings us to the end of this session. I want to say thanks to everyone who participated, and I think this was a good presentation. Sir Howard Chin, as the mechanical engineer chairman, I think this is a good start. We will, given your clearance from everyone, we will try to have this. Well, the video is recorded, so we want to have it available to all members so that we can increase the knowledge and also sensitize persons to the importance of welding in Jamaica. So on that note, I'd like to say thanks to everyone who participated, and look forward to having more discussion on this topic and to see how best we can improve the state of welding in Jamaica. All right.
Oh, by the way, Kevin.
Yes.
One thing before you wrap up. You see the exposure time for low hydrogen electrodes. It is pretty critical, but it's not quite as short as Julian says, but only in cases where you have very high strength electrode. Then you have the really short times that you can expose it to the atmosphere and moisture. So if you have, after you break open the package of electrode for the low hydrogen weld that you're going to do, you have only a very short time, maybe 1 hour or so, to actually get the thing done, or you have to hold it in an oven for at minimum 250 degrees Fahrenheit until you're ready to use it. And if it ever gets wet, you got to dump it. It's only able to be reheated or baked out once, and that's it.
Okay.
So a lot of people not complying with that. Okay then.
Noted.
Right.
I'm sure this will be very informative to the general body. It's an information presented, and as we try to continue the educational units as is required for professional engineers, I'm sure this information will be of great worth in terms of updating their knowledge base as it relates to welding and the building code. Again, I just want to say thanks to everyone, and we look forward to having more discussions like this. And thank you for making the time out. All right.
Okay.
Over to you,
Hi,
Chair.
Kevin.
You can say the last goodbye.
Who's it?
No, on to you, the chairman.
Oh, sorry. Okay. Yes, so that I hope that it was informative, and let's get going on some other things as well, which will improve the state of engineering and the engineering works that we do.
Agreed.
That's it.
All right. Take care, everyone.
Okay.
All right, take care. Have a good day.
You too.
Right.
Okay, bye. Thanks for having me.
Thank you, Sir Scott. Thank you. Thank you. Thank you.
Gentlemen, it was a pleasure participating in this very important seminar, you know, and as an engineer with long standing, this come like a continued education for me. So gentlemen,
Exactly.
thank you very much, and I will try my best to participate if I get the information. And Scotty, long time we haven't seen you. Take care.
Scotty mic muted, man. All right. Take care, everyone.
Okay. Bye.
Okay, Peter,
All right.
thank you. Take care too.
All right. Mr. Chin will talk. All right.
Yes, indeed.
Okay, Howard, we talk.